Okay, this is video 2 in our series in this lesson, and we talked a little bit about sodium handling by the nephron and chloride handling. We concentrated particularly on the proximal tubule. Now I'd like to talk to you about how the nephron handles water. So just as an overview, just to remind you, water reabsorption takes place secondary to osmosis. All right, you need a water gradient in order for water to diffuse. So high osmolarity means low water concentration. You diffuse from low osmolarity to high osmolarity. And so when you reabsorb solute, you create a higher osmolarity if you're reabsorbing, on the interstitial side of the epithelium. And so what that means is water will naturally follow the solute and diffuse down its gradient. And that is what drives water reabsorption everywhere in the nephron, okay? One significant point to make, and this is tricky, you know, we talked a lot about water following sodium around in the last video, but it can't always do that, because you need to be able to handle situations where maybe you eat a lot of salt, but you need to urinate a dilute urine. So if you eat a lot of salt, you know, you have to get rid of a lot of salt, but that's not always what you have to do with water. Sometimes you'll drink a bunch of water and have a normal amount of salt. So you need to be able to create a dilute urine so that you can get rid of a bunch of water but not that much salt, because you want what you took in to be what goes out. So in that situation, if I drank gallons of water and just had a normal amount of salt, I'd want to be able to generate a dilute urine. I wouldn't just want water following salt around, because that would mean I'd have to get rid of a lot of salt in order to get rid of a lot of water, and you can't have that. So you need to be able to separate these two, and we'll talk a lot about how that's done, okay? So a quick comparison of the handling of the two. In the proximal tubule, equal amounts of water and sodium are reabsorbed. So there it works. Water just follows the sodium around, okay? And the vast majority of both, or the majority of both, are reabsorbed in the proximal convoluted tubule. Water and sodium are both reabsorbed in the loop of Henle, but they are reabsorbed in different regions. The descending loop of Henle is permeate to water. So water is reabsorbed in the descending part of the loop because it can get across. And as you guys know, the medulla becomes more concentrated as you get down into the medulla. So, as the osmolarity gets higher as you go deeper into the medulla. So as the osmolarity gets higher, water will naturally diffuse from the tubular fluid into the medulla, and you will reabsorb water. Now, in the ascending loop of Henle, that is water impermeate. Water cannot get across that membrane, but sodium can. It's transported out of the tubular fluid here by the sodium-potassium 2 chloride pump. So here, we've separated water reabsorption from sodium transport, sodium reabsorption. One happens in the descending part of the loop, one happens in the ascending part of the loop. You get 5% sodium transported out of the tubule in the distal convoluted tubule. It is also water impermeate, okay? And then most of the control, well, all of the control of whether you're going to get a dilute or concentrated urine, at least physiologically, happens in the collecting duct. And here we have both sodium and water reabsorbed, but the amount reabsorbed of each is variable, and it is controlled by things like aldosterone and antidiuretic hormone in that collecting duct, okay? All right. So, what defines when water moves? Water will move down an osmotic gradient. There's no such thing as a water pump, okay? So you need water moving from high concentration to low concentration, and Water moves only if it can, which means it only moves in segments of the nephron which are water permeant. You guys know the vast majority of the cells in the body are water permeant. And in fact, the kidney is, as far as I know, it's the only place in the body which has membranes which are not water permeable in the ascending loop of Henle and in the distal convoluted tubule. So, but if there's a way for the water to get through, it'll go through. It varies with that. All right. The proximal tubule, very water permeant, and so as the sodium is transported out of the proximal tubule, the water will follow. The sodium, as it's transported across, creates a water gradient. It locally increases the osmolarity. It doesn't increase it much because water will immediately follow. You can't have a water gradient with a very permeable membrane like that, okay? And then in the loop in the collecting duct, the gradient is created by the high sodium and high urea in the medulla, okay? So this is where what powers our water transport there, okay? Basolateral membranes are always water permeant. The apical membranes are not. They are in the proximal tubule and in the descending limb. I told you that's where a lot of water reabsorption takes place. In the ascending limb and the distal convoluted tubule, no water reabsorption takes place. We're getting sodium transport there. And then in the collecting duct, you have some water permeability, and it's regulated by things like antidiuretic hormone. We'll talk about that, okay? So what happens when the water permeability of the collecting duct is very low? Well, what happens is the water can't get across the collecting duct. So as your tubular fluid goes down here, you have a high osmolarity in the medulla, so there's a driving force for water to go from the tubular lumen to the medulla, but because the membranes are impermeant, the water can't get across, so you get a dilute urine when the water permeability of the walls of the duct is low. If there's a high permeability, now the water can get across, and so you lose water from the tubular fluid and the urine becomes concentrated, okay? So remember HTO moving down an osmotic gradient, okay, that's what powers it. And only if there's a pathway for it to get across, only if the epithelia is water permeable, and how much depends on the size of the gradient and the degree of the permeability to water, okay? Particularly in the water permeability, it's regulated in the collecting duct. Okay, so let's end our video there, and we'll start the next video with sort of like combining the water and the salt transport and going through some of the nitty-gritty details.